Namaste friends, my name is Nisha Thakur and I am a maths online tutor. In this series we are learning polynomial functions and their graphs and using zeros to graph a polynomial function. We already done one question and you are familiar with these guidelines for graphing polynomial functions. So if given any function, first you have to factorize, then find out zeros, which is called x-intercepts of the graph. And after the finding zeros, you can choose test points between zeros, successive zeros, and then you can use their intermediate value theorem, and you can easily observe graph above or below the x-axis. Okay. And behavior, so determine the end behavior of the polynomial. These three things we already done in my last videos, and then you can easily graph them. You can find out more points, so you can sketch a smooth curve that passes through these points. Okay, here is today's question: finding zeros and graphing a polynomial function. Let px equal x cube minus 2x square minus 3x. Here A question, find the zeros of P, and B question is gives a graph of P. So first find out zeros of. Now A question, factorize Px. So from here we can take common x. So x square minus 2x minus 3. Now we can factorize this quadratic polynomial. Here product is minus 3 and sum is minus 2. So we choose two numbers which product is minus 3. So 1 times 3, and product is negative, it means different sign, and sum is negative, it means larger number, negative. Okay, so 1 times minus 3 is minus 3, and 1 minus 3 is minus 2. So we got two numbers, 1 and minus 3. Now we can easily find out zeros. So x is equal to 0, x plus 1 equal to 0, or x minus 3 equal to 0. So x is equal to 0 is this, and this is x is equal to minus 1, and this is x is equal to 3. So these are the zeros, 0, minus 1 and 3. So the x-intercepts are 0, minus 1 and 3. We can rearrange in ascending order. So minus 1 comes first, then 0, and then 3. These determine intervals minus infinity to minus 1, minus 1 to 0, and 0 to 3, and 3 to infinity. Okay, so number line divides into four parts: minus infinity to minus 1, minus 1 to 0, 0 to 3, and 3 to infinity. So we make a table of values of px, making sure that we choose test points between successive zeros. And one important thing here, y-intercept is also 0, because when we put x is equal to 0, px is also 0. So y-intercept at 0 at origin. Okay. And can you see here, this polynomial degree is 3, because highest power is 3. So this polynomial degree is 3, which is odd. And here leading coefficient is positive. So our graph kind of like this. Okay, so end behavior is y tends to infinity as x tends to infinity, and y tends to negative infinity as x tends to negative infinity. Okay, so here zeros are at -1, 0, and 3. Okay, so when we put these values, px values 0, it means these are x-intercepts or zeros. Okay, between minus infinity to -1, we choose -2, and when we plug in px, we get -10. It means this is below the x-axis graph. Here, from -1 to 0, we choose -1 upon 2, so we get positive 7 upon 8. It means above the x-axis graph. Okay, and from 0 to 3 test point, we choose x is equal to 1. So when plug here x value 1, we get -4. It means graph below the x-axis. Here we found extra point 2, we got negative, and this is below the x-axis graph. Here, 3 to infinity, we choose test point 4, and when we plug px, so we got positive 20. It means graph above the x-axis. And this is the graph for the given polynomial. Okay, here this -1, 0, and 3 are zeros, -1, 0, and 3. Minus infinity to -1, we choose -2, so we got negative 10, and this is below the x-axis, graph below the x-axis. Between -1 to 0, here we got positive, it means graph above the x-axis. Again 0 to 3, here 0 to 3, here both values negatives, -4, -6, so graph below the x-axis. And here more than 3, 3 to infinity, we choose 4, so we got positive 20, and this is um, graph above the x-axis. So is case the graph of any polynomial now easier for you? But if you have any doubt, please ask me, and if you liked my video, so please like, share, and subscribe my YouTube channel. Bye, have a nice time.